Hello! We would like to present to you a short video demonstration of Mender, an Apache-licensed open-source project to deploy over-the-air software updates to connected Linux devices. Whether your target market is the Internet of Things, automotive infotainment, or other embedded Linux applications, Mender provides a simple and complete solution for maintaining your device fleet. Given the recent internet outages caused by large groups of consumer-grade Internet of Things devices, as well as ongoing automotive security concerns, it is clear that a stable and reliable update process is a must-have for development teams in these markets. Mender is a fully end-to-end open-source solution. Both the back-end management server and the runtime client component are open-source with an active developer community. In this video, we will show you how to deploy a software update. This is the Mender dashboard showing a number of devices in our fleet. Note that these devices do not need to use the same hardware. In this setup, we have several emulated devices running QEMU ARM emulation, as well as a BeagleBone Black platform. In this dashboard, you can also drill down on each device to review identifying information, including target hardware types and MAC addresses. Before rolling out a new update, let's group a few devices together to allow for campaign management of a release to only a subset of our fleet. In this case, we will select both a QEMU device and a BeagleBone device to test our update. Now we need to add Mender artifacts to the backend that can be deployed to our devices. Note that we have to use two different artifacts as our devices are different hardware types and do not run the same binaries. To begin the software update process, we will need to create a deployment for each release. From the deployment screen, you select which artifact to install, as well as which devices to use. In this case, we will use release 1.1. While that image updates, let's review the partition setup used by Mender. The Mender updater requires two static partitions, a boot partition containing the U-boot bootloader, and a data partition which contains data files that are persistent between updates. These two partitions are unmodified by the Mender client. Additionally, there are two root file system partitions called the active and passive partitions. These are used by the Mender client to handle system updates while maintaining a robust rollback capability. Now we notice that our updates have failed. Fortunately, we only tried to roll this out to a small subset of our fleet, and the bad update was detected and rolled back automatically by the Mender client. Fortunately, we now have release 1.2, which contains a fix for the issue that caused our previous update to fail. We will trigger a new deployment with the fixed release, and with a bit of speed up on the recording, we see that the update succeeded, and all devices from the early adopters group have now been updated to release 1.2. You can set up Mender to manage your fleet of Linux devices today. Just go to mender.io. You can also contact us with any questions by sending an email to contact@mender.io. Our team is more than happy to help. Thank you for watching this demonstration.